Welcome to the Neural Network podcast. Today we are here with Dr. Eric Chudler, a neuroscientist and research associate professor at the University of Washington with affiliations in the Department of Bioengineering and the Department of Anesthesiology and Pain Medicine. He is also the executive director and education director of the UW Center for Neurotechnology. Eric received his undergraduate degree in psychobiology from UCLA in 1990 and also his PhD in psychology from the University of Washington in 1990 as well.
Actually, 1985.
1985.
Right, 1985. In addition to his research, Dr. Chudler works with other neuroscientists and classroom teachers to develop educational materials for K-12 students to help them learn more about the brain.
Yep. So to start off, we have a few questions about your favorite aspect of of the field you study. What are some favorite aspects of that?
Favorite aspect of my research?
Yeah.
I think just in general, finding out new things that no one has seen before is some of my favorite parts of research. One of my favorite projects was working on how neurons in the basal ganglia respond to somatosensory information. The basal ganglia have mainly been thought of as being involved with functions related to movement. For example, people with Parkinson's disease they lose dopaminergic cells in the brain, and that causes a movement problem. Well, I recorded from neurons in the basal ganglia that respond to somatosensory information, which nobody really had thought of before. And about half the patients with Parkinson's disease, they have pain problems. And nobody really knew why someone with Parkinson's disease would have pain problems. And so in my recordings from neurons in the basal ganglia, specifically the caudate and putamen area of the brain, I showed that those neurons responded to painful information, which hadn't been seen before. So discovering something new that had never been seen before related to a human condition was something that I found very, very interesting.
What are some exciting possibilities that you found in during that process of your research?
Well, it led to some other questions. So this was several years ago when I did this work, and this work was performed in rats. And so one study that I proposed, I submitted a grant application, but it didn't get funded, was to survey patients who had Parkinson's disease. There had just been starting to be some evidence about the incidence of somatosensory and other sensory problems in Parkinson's patients. And so I did a pilot study in human patients asking about the quality of their pain, if they had pain at all. And so some of that animal work I tried to translate into some human research as well.
Wow, that's amazing. And how does being in research impact your lifestyle? I mean, what does your life look like outside of the lab?
I think neuroscientists, professional researchers, we're people, and we do have a life outside of the lab.
Yeah, of course.
But for me, doing research is something that I would probably do even if I wasn't paid to do it. I think that most people in academic research um, contribute much more than just 40 hours a week. We think about it outside of work. We work on our projects outside of work. We write. We mentor outside of the usual 9 to 5 job. So it's a very time consuming profession, but I think it's very rewarding. And I think perhaps for me, the top reward is seeing students who I've mentored, students that I've advised go on to the next level and become successes on their own. So it's a very rewarding profession, but yes, very time consuming. But I have hobbies outside of the lab. I've been playing basketball for more than 50 years.
Wow.
I still play basketball now. I do photography, I garden. So there are things outside of the lab that keep me busy, but it is more than a regular 9 to 5 job.
Wow. very, very dedicated.
Yeah, but I don't think I'm that unusual. I have lots of colleagues, lots of friends who are researchers, and they too have hobbies outside. Um, just like everyone else, it does take a bit of a balance. You know, the work and home atmospheres have to balance each other. But I think it's healthy to have interests outside of the lab to help that balance.
Of course. And what fulfills you more about being in research itself?
Well, as I mentioned before, I think discovering things new, discovering things that people haven't seen before, that's very, very rewarding. When you do an experiment, you don't know how it's going to turn out. You might have an idea, but oftentimes you're surprised with results, and it doesn't always happen the way you think that it will. The results are not always what you expect. And so some of those surprises are very interesting, rewarding, and surprising.
Absolutely.
Connecting back to your like when you are saying you're mentoring your student and um like love to seeing them succeed. What are some like I want to start up with the process of like what did deciding go to grad school and like ending here look like for you?
Well,
Yeah.
for me, getting to graduate school may be different from other people's experience. People get into graduate school in lots of different ways. When I was an undergraduate at UCLA, for the first 2 years, I didn't know what I wanted to do. At UCLA is not so far from the beach, so I thought that maybe I can get a job at the beach doing something. And my dad wasn't too happy about that. But I didn't take any psychology classes or any. I didn't even take any biology classes in my first 2 years. I took calculus and physics, chemistry in my first 2 years because I liked science. But it wasn't until my junior year at UCLA where I took a psychology class where the professor was, back in those days, was called a physiological psychologist. These days would be called a neuroscientist. And this was one of those large survey classes with 300 or 400 students. And this professor was talking about his research. His name was Dr. John Liebeskin, who was one of the first to discover how the brain makes a particular neurochemical, the endorphins, in times of stress to reduce pain. And he was telling the students about that and asked any students that were interested in his research to come see him after his lecture. And I was one of a small group that came up to him after his lecture, and he escorted us, about 3 or 4 students, to his lab, introduced us to some of the graduate students and the postdoctoral researchers in his lab, and then said, "If you're interested in my research, come see me tomorrow." I was the only one that showed up the next day. And so for my last 2 years at UCLA, I worked as an undergraduate researcher. Performing research, he sent me to conferences. I even was able to publish a couple papers as an undergraduate in his lab. And when it was time to graduate from UCLA, Dr. Liebeskin asked me, "What are you going to do next?" Neither of my parents are in science. My parents were school teachers. And so they didn't really have any advice for me. But Dr. Liebeskin told me about this thing called graduate school. I said, "Oh, graduate school, what's that?" And he said, "Well, you go to school for about 5 years, some people more." And I said, "Go to school for another 5 years? What do I want to do that for?" Getting out of high school, from elementary, middle, and high school, 12 years plus 4 years at UCLA is 16 years of education. Why do I want to go to graduate school for another, 5 years? And he said, "Well, don't worry. Mainly what you do is research. Yes, you have to take some classes, but mainly what you do is research, and you seem to enjoy research." So I said, "Oh, that's true. I'll try that." And he said, "Not only that, but in the sciences, you get paid." So graduate students in the sciences get their tuition paid in most cases, a stipend, not a lot, and benefits. And that's enough to live on. So I applied to a couple of different graduate schools. I got into a couple of different ones. And I decided to come to the University of Washington for my graduate training because they were able to offer me this package for the entire duration of my graduate career. So that's how I approach graduate school. These days, I've noticed that many students take a break between their undergraduate and their graduate work. I didn't do that, but many students do take a break. It's not that Well, some do travel the world, but many students get a postbaccalaureate research position. Some students work as lab technicians for a year, gaining new experiences and skills, techniques, and then they apply to graduate school. I didn't do that a long time ago, but I've seen many students do that now, take this short break between undergraduate and graduate school just to get their portfolio a bit stronger so that they'd be stronger candidates. So that's how I approached graduate school, directly from undergraduate to graduate. But many students, many people don't take that direct route.
Absolutely. Just to follow up on that, so you graduated from UCLA in 1980, and then that same year you came to University of Washington to pursue your grad school and your PhD, right?
Yeah.
And in that process, were there any challenges? I mean, like you say, a lot of people take breaks in between undergrad and grad, but you going straight from undergrad to graduate in that 1 year, what challenges did you face, and was it like a big change all of a sudden?
Well,
Also because you had to move cities and everything.
yeah, well, the biggest change for me is that when I accepted, I didn't do an interview. A lot of students do an interview for graduate school. We didn't do that back then. The biggest challenge for me was I had never been to Seattle before. So I took the offer, I accepted the offer completely unseen, never having been to Seattle before. And this was also in the spring of 1980, which is when Mount St. Helens blew up. So I was thinking, what am I getting myself into? I'd never been to Seattle before.
Yeah.
And back in those days, there was also no internet. So we did things by mail or by phone. And so I had the address of my advisor, I was sort of what we call now a direct admit into a lab. And so I had the address of my advisor, and I was able to find my way to his house. So I just loaded up my Toyota Corolla with a couple bags and some pots and pans and drove up I-5. Never having been to the state of Oregon or Washington ever in my life before. And I found my way to my advisor's house, literally to his house. I knocked on his door and I said, I'm here. And he allowed me to sleep in his basement for about 2 weeks or so until I found my own apartment. So yes, changing cities, especially if you've never been to that area, it can be challenging. But I found the change somewhat easy, perhaps because of my background. As a child, I moved around a lot, and so I was kind of used to moving. So moving to a new city, making new friends and contacts wasn't a big issue. And the lab that I was in was a relatively small lab, and so it was easy to kind of acclimate myself to the new environment.
Wow. Okay, so you just drove straight from LA to your advisor's house
Yeah.
in Seattle, and then
I stopped once in Southern Oregon at a motel just overnight because it took me about 2 10-hour trips.
it's a long drive.
It is a
Yeah,
long drive, but yeah, especially in a little Toyota Corolla over some of the passes.
Yes. Oh wow. Wow. That's incredible. What a story.
And what did you like? What surprised you and like didn't expect about your graduate school after you getting here?
Well, I mean, starting graduate school, it's a very gradual process. It was for me. So the first year and a half, almost 2 years, you're still taking courses, and so to get that background information. But I think being able to balance the time spent in the lab versus those classes and courses you have to take is a little difficult. But my advisor was very welcoming to me, and very was able to give me the skills that I needed to succeed. So as just I think balancing schoolwork and coursework with research, it can be a little challenging.
Absolutely. And with regards to grad school, what surprised you, or even what didn't surprise you about it?
Well, I don't think that anything was really surprising. Nothing like sprung up on me. I suppose later in graduate school, what was perhaps surprising, and it continues into work as a professor, and that is the amount of writing that you have to do. So, along the way to my PhD, I actually got a master's degree. And so you writing up that master's thesis, and then once you do your PhD work, you need to write that up. And not only is the writing of your dissertation something that you have to do, but a lot of the things like protocols and human subjects or animal research, IRB type things have to be written. And so, one thing that's, I think, surprising, not only in graduate school, but also after your graduate degree, whether you become an academic or perhaps in industry too, is the amount of writing that has to be done. And so I wish that when I was in high school and also as an undergraduate, I wish I took more writing classes. And I think by becoming, I kind of learned how to write in graduate school. And so that was, I think, the most surprising thing is the amount of writing that needs to be done. And so I think becoming a good writer is something that's very important that a lot of students don't think about.
Absolutely. And well, you gave advice about writing, obviously, and is there any other crucial advice you would give for um, a grad student to be successful in your field?
I think take care of yourself, mentally and physically. And what I mean by that is sometimes things can be very stressful. There's a lot of deadlines that are imposed on students. So be prepared. Don't go in blindly. Don't procrastinate. Because I think time management is something that we talk about, but really isn't a skill that's taught. So being able to manage time between early on your classes and research is something that's important, but also giving yourself time off to kind of get yourself away and just think about things instead of having to do things in the lab. So being able to take care of yourself mentally and keep yourself physically fit, I think all contribute to a successful graduate career.
Yeah.
Absolutely.
Yes.
Great advice.
Yes. And I would like to like go back to before your graduate school. So what would you tell undergraduates who interested in research or like in any science field? Like what would you tell them to be successful when they
I,
go
I
into
yeah,
yeah.
I would say early on, don't limit yourself to one particular domain. I think that it would be good for a student to try to sample lots of different things until they find one that really resonates with them. As I said, for me, my first 2 years, I didn't know what I wanted to do. I thought I never wanted to go. I never wanted to be a physician. That was something that did not interest me. So I took classes in geography. I took classes in oceanography, and I tried to sample lots of different things until in my junior year I found that psychology and neuroscience pathway for me. So I didn't try to limit myself, and I think that's something important for undergraduates to sample as many things as possible. I mean, a place like the University of Washington is great because it's such a big place. No matter what a student wanted to study, there's a class for them. And so, I mean, it's a bit of a hackneyed expression. I don't like to use it, but I'll use it now. And it is, oh, find your passion, whatever that is, right? That's what they tell students. And I don't really like to say that, but I think it's important for students to sample lots of different disciplines until they find something that really resonates with them, and that's something that they could see doing if you didn't get paid to do it.
Yeah.
I remember when I was an undergraduate, one of my two of my favorite classes. One was a invertebrate biology class, And this was taught. I still remember his name. His last name was Hamner, Professor Hamner, and he would take us out into the bay around Los Angeles. We'd dredge the bottom of the ocean, and then we'd bring our samples back to the lab and study them. And I thought that was the greatest thing ever. So I didn't become a marine biologist, but that class, I think I could have become a marine biologist, and that class was something that I just took just to sample it. Another class was a psychology class where it was a lab class where students were given, I think in pairs, we were given one rat to two people, and we studied self-administration of electrical stimulation, so self-stimulation. So we'd implant an electrode into the brain, into the medial forebrain bundle of a rat, and they would self-stimulate to get electrical stimulation. It's very rewarding. And we did this as undergraduates. And again, these hands-on experiences, I think, were very, very important. So I think for students to get those lab classes and sample lots of different fields is very important until they find something that really is something that interests them. So take as many classes as possible. I know that students are under pressure to pick a major because you do have you can't be an undergraduate forever, and you do have to pick a major, and there's certain requirements that you have to fulfill for particular majors. But I think the first 2 years, as long as you're interested in science, you can get some of those prerequisites out of the way, and then really focus on what you want to do your last 2 years.
Yeah, that is wonderful. One really fun thing is that like when I look at the registration system, and like for some sort of major, they also include like different disciplinaries. Like for example, if like someone wants to go to like natural science field, but they also have to like fill out the social science credit and like humanities. So I think that is like really interesting.
Right.
Yeah.
I remember even when I was an undergraduate, because I had to fill some of those social sciences requirements at UCLA, I took a history of India class because it sounded interesting, but and it was one of the few classes that I think was still open for me to take. But yeah, I was able to sample lots of different things. I took an English literature class. I took children literature class. So I was able to take lots of different classes. But I know that once you pick your major, especially in those last 2 years, your curriculum is pretty well set. But at least for the first few years, you get to sample lots of different classes.
That's wonderful.
Yeah, that's the fun part. So obviously you've done a lot of amazing research, and you said how rewarding it is, but what are some of the biggest challenges and setbacks you've had in the process?
Yeah, well, certainly every grant application that I've written did not get funded. And so there is a lot of work that sometimes goes into projects or applications that is not fulfilled. And I don't know anybody that has a 100% hit rate on a grant application. So that can be very disappointing because writing a grant application can take weeks or months to do. And you spend a lot of time and a lot of energy putting work into something that may or may not get funded. And so that's a bit disappointing. It takes a bit of perseverance, and oftentimes, even if a grant is not funded, if the reviewers of that grant are good reviewers, you'll get some positive feedback. What you did right, maybe some ways that you can fix up the grant. And so by revising a grant application, you can make it stronger. Same thing goes with research papers. Oftentimes, when a paper is submitted, it may not get accepted on the first time. It may be, I haven't had too many papers outright rejected, but oftentimes they come back with either minor or major revisions are expected. And so, if the reviewer is good, it helps the paper, and you just revise it according to reviewers' suggestions, and then it's published. And so it's a little disappointing sometimes when you submit a paper and it doesn't get accepted in the first time, but that's actually somewhat rare that it gets accepted as is. But when you get that feedback, hopefully it will make that paper stronger. So, but it's always a little disappointing when a grant application or when a paper that you've worked on for such a long time doesn't get accepted. Uh, it just takes a little bit of wherewithal to continue moving forward, making revisions, making it stronger, making the work better.
Definitely. So actually about that, so I haven't written like an actual grant application, but I've done a mock one. I'm really interested in the whole process. And the thing is, it has to be like rhetoric. You have to convince them why you should fund my research, right? And in that process, from those rejections, what's the single most important thing you've learned to keep in mind when writing grant applications?
Yeah, I think telling a story. There, grantsmanship is difficult, and people come at it at different directions. But I think telling a compelling story is what grant reviewers look like. Oftentimes, and I've sat on NIH grant review sections, so I've reviewed grants myself, I've reviewed papers myself. And as a reviewer, the simpler that you can make things, the easier it is for a reviewer to understand what you're trying to say is best. Sometimes all the jargon in the world is not going to help you. In fact, it could probably hurt you. So, making your story compelling and making it simple to understand, I think, is one of the most important things of grant writing. Uh, Oftentimes, depending on the grant that you write, the type of grant you write, you need to show some progress in or background work that you've done to make sure that you're qualified to do the work. But I think that making a grant application simple to understand is perhaps the most valuable aspect of grant writing. Um, because if you can't write clear, and this comes back to what I said before about taking writing classes to make your ideas as clear as possible is what's very important. Also, I think in, and again, it depends on the grant application, but having pictures, having figures, having graphs to illustrate what you're trying to say is also very important. People are very visual. And I think by having images to illustrate some of the things that you want to talk about is also very important.
Perfect. I'll keep that in mind.
Perfect. So in everything that you said, I found it really interesting and like wonderful, and especially the class that you talked about the history of India and also like the English literature, um, like and from that, I've also seeing that you are also doing a lot of education and outreach, um, for children, like to educating them about the brain. And I'm wondering, could you tell us about a little bit more about the education's
Sure.
program that you are doing?
Yeah. So as I mentioned earlier, both of my parents were school teachers. My dad was a elementary school teacher, and then he became a vice principal and then a principal of public schools. And my mom was an elementary school teacher as well. So I think that maybe teaching is maybe a bit in my blood. But when I had my own kids, my daughter is now 35 years old, and my son is probably 32. When my daughter was in preschool, they had one of these show and tell kind of events. You know, when the parents would come in and talk to the kids about what they did. And when it was my turn, I guess my daughter must have been 3 or 4 years old at the time. What I told the kids about was about how their brain works. These were really young kids. And that was my first experience teaching children. As university professors, most of us are not trained educators, right? We've been in classes a long time. We're around students a lot, but we're not trained to teach. And so this was my first experience, although I guess as a graduate student, I did TA one class. But this teaching 3 and 4 year olds about the brain was very, very new to me. But I decided to teach them about their senses. And so what I did is I brought in a bag of potato chips. And I asked these kids, I held one potato chip in my hand. I said, "How do you know this is a potato chip?" And the kids said, "Oh, we can see it." And so I ate the potato chip, and they thought that was funny. And so I brought out another potato chip, and I said, "Yes, you can see it, but how else do you know that this is a potato chip?" And they said, "You can taste it." And so I put that in my mouth and I ate it, and they thought that was funny. And we went through the senses in this way. If I crushed the potato chip, you can hear it, you can smell it, and you can feel it. And so we went through our five senses like that. And I didn't have a lot of time, and a 3 or 4 year old doesn't have a long attention span. But we talked about our senses and how the brain is responsible for processing all that information. I didn't use the word processing. But from that day on, I thought that maybe because teachers were not trained neuroscientists and often don't have neuroscience as part of their educational background, I thought that maybe I could develop something that would help teachers incorporate neuroscience or brain research into their own curriculum. And as my daughter moved up in grade, I guess word spread that there was this guy from the University of Washington who would come to your class and talk about the brain. And so I would go back to my daughter's class teaching the older and older kids. Once she got into middle school, she stopped asking me to come to her class. But by that time, I had developed the resource called Neuroscience for Kids. And this was back in the late 1990s, where the internet was just starting to become what it is today. And I thought, well, this thing, this internet thing, this World Wide Web, maybe it could be used to educate people. And so I taught myself HTML, and a lot of the activities that I was doing in classrooms, I put on websites, on the Neuroscience for Kids website. And teachers would use it, download some of the materials to use with their own classes. And so that's how I got started, by creating this Neuroscience for Kids, sending it. Everything's freely available for teachers around the world to use. And so that's how I got started developing some of these educational materials and started my outreach. And then I got involved with Brain Awareness Week, which is a program that Gray Matters, as well as a lot of the graduate programs here at the University of Washington, the Neuroscience Community Outreach group participates in Brain Awareness Week, trying to develop more outreach through that organization. So I became involved in other outreach that way. And I was able to write grants to support it, because as my appointment here at the University of Washington is as a research professor. And that research in front of my name means that my salary has to come from grant support. And so all of my educational activities have been supported with grants, some of them from the National Institutes of Health, some of them also from the National Science Foundation. So my education and outreach work has been supported by outside organizations like NSF and NIH.
Amazing. Now, Dr. Chudler, as the executive director of the Center for Neurotech at UW, what are some things that the center is doing to advance neurotech and to drive innovation in the field?
Yeah. Well, so the Center for Neurotechnology was developed through a grant from the National Science Foundation. Our current co-directors are Dr. Raj Rao and Dr. Chet Moritz, who are our center co-directors. And the center was set up to take advantage of the neuroplasticity of the nervous system. And we thought that engineering neuroplasticity through, for example, stimulation of the nervous system may benefit people who have spinal cord injury or stroke. So we're trying to better understand how the brain changes over time, how stimulation of the brain may help repair or rehabilitate conditions, or people who have conditions like stroke, spinal cord injury. It may even have applications for Parkinson's disease, although we're not, or Alzheimer's disease, although we're not studying psychiatric disease at this time. So we're trying to take advantage of how the brain can change and how to use that for rehabilitation.
Wow, that's amazing. How long, by the way, has it been going for?
So the center was originally established in 2011. Our original director was Yoki Matsuoka, who was a professor in computer science and engineering. And then she left the University of Washington, and then Tom Daniel, who is a professor in biology, took over as our interim director for several years. And then Dr. Moritz and Dr. Rao have been in as co-directors for the last several years. So since 2011, our funding actually, NSF says sunsetted, which really means expired, several years ago. But we still are helping develop these technologies.
Wow, that's incredible.
Yeah.
Well,
Um,
the next steps?
yes. So from that, what are you looking forward in the future of the Center for Neurotechnology?
Well, as executive director, I take my marching orders from Dr. Moritz and Dr. Rao. We're certainly looking for more funding. When we had NSF funding, we were able to fund mostly graduate students to work on projects related. Without this funding, we can't fund graduate students like that. So we'd like to get some more funding so that we can sort of ramp up like we once were. For the past several years, we've had a research experience for undergraduate program. So we ran that program even after National Science Foundation funding for the center expired. I wrote an NSF grant that funded 10 undergraduates, and we put them into labs for 10 weeks during the summer. Just because of funding issues, we're not going to have that program this particular summer, but we hope to revive that program as well. And many of the students, we've had 10 students for the past almost 14 years, so close to 150 students. And many of these students have gone on to get their PhDs. Some have gone on to medical school. Some have transitioned into industry positions. Some for the more recent years are still undergraduates, and some are just starting to enter graduate school now. So we'd like to continue our research. We'd like to continue our educational programs, not only for undergraduates, but for high school students. In fact, this summer 2025, we have a 1-week camp. It's called the Young Scholars Program REACH, which we have 24 students that will be on campus for a week, learning about neurotechnology, learning about neural engineering, learning about neuroscience, and almost 150 students that will be learning about these same things virtually. So the virtual students receive just lectures. So I give an introductory lecture, but then Dr. Moritz, Dr. Amy Orsborn from Electrical and Computer Engineering, Dr. Jeff Heron from Neurological Surgery, and Dr. Sarah Garing from Philosophy. She'll be talking about neuroethics. The virtual students get all these lectures. The students that are here in person get those lectures plus activities in the afternoon. So the center will continue on with a lot of these education programs as well. And not only that, but we also host field trips for local schools, elementary school, middle, and high school students come to the center where they learn more about these technologies too, in the hopes that they're motivated to maybe pursue neuroscience or neural engineering in the future.
Very cool, very exciting stuff. And what excites you now about the next journey of your career?
Well, my next journey is well, things. I'm in transition right now. I guess is the best way that I can say. So next month, I'll be transitioning. It's not official yet, but I hope to be transitioning to a new type of position at the University of Washington. I'll just leave it at that.
Okay.
Yeah.
All right. Let's see. We'll see what it is. It'll be a surprise. Well, that's all the questions we have for you today. Do you have any questions for us?
Yeah. Who's next on your list of interviews?
We actually don't know yet. But for now, you're the only one.
Uh-huh.
The chosen one.
Yeah.
But we'll see if we'll have another interview. Maybe this might be the only one this quarter.
Yeah.
Um,
Well, as you know, I mean, the University of Washington is just filled with neuroscientists
Yeah, oh,
doing
yeah.
cutting edge work.
Definitely.
So there's lots of fantastic people that are just doing fantastic work here at the University of Washington. So I'm sure you won't have a choice. You won't have a problem finding somebody else to speak with.
Absolutely. We might actually interview you again after, your next step in your career. So let's see.
Great.
Yeah.
We might have a
we'll
part two
see.
for this.
Yeah.
Yes.
Well, thanks for having me.
Absolutely. Thank you so much
Yeah,
for
thank-
joining us today. It's been a real pleasure.
Yeah,
Great.
it's wonderful to learn about your careers and like your journey. To see like to learn more about you and like it's really meaningful for the other people like to know the path that getting you to like research having interest in neuroscience and to research. So it's really really meaningful
Yeah.
having
And
you here.
and I just want to emphasize that there is no one path.
Mhm.
Yeah.
People come to neuroscience from so many different ways. Not only their academic background, but their family background, their cultural background. They come from all different places, and I think neuroscience is a very welcoming community. And there's no right way. People can approach neuroscience and get into a career in neuroscience from lots of different ways. Not only from the natural sciences, but from engineering, and now with from the humanities as well, neuroethics, law, even marketing, all perhaps have avenues into neuroscience. So if a student is not interested in bench science, there's many other ways to enter neuroscience if they're interested in how the brain works.
Yeah.
Absolutely. The sky's the limit.
Yeah.
Yes.
Well, I think that
Thank
wraps
you.
up
Yeah.
our
That's
podcast for today. So thank you so much for joining us, Dr. Chudler.
Thanks for having me.
yes. Thank you so